Good afternoon, class. This is Miss Hayden, and I am obviously not here today. I am with the 7th graders on a field trip. And so today I created a screencast for you to show you today's lesson. So let's first talk about what's going to be happening for the next few weeks. Now, since I'm not there today, we will not be having the electric circuit lab, obviously, because I'm not there to help facilitate the lab. And that is the next thing we have to do. We just have to take a little bit more notes, kind of solidify our notes on electric circuits, and then it's time for the lab, and we're set with that. So we're going to do that tomorrow. So we'll finish up our notes tomorrow and start the electric circuit lab so I can be there to facilitate it. What we're doing today and what we'll be doing after the lab is what we'll be doing for the rest of the year, and that is graphing and interpreting data. And this is a really important skill for you guys to have to be good scientists, right? Because it's all part of the scientific method. We make our hypothesis, we test our hypothesis, we collect our data, and then we analyze our data. So that's what we're going to be doing today. So let's go back and review what we already know about interpreting and organizing our data. And that is line graphs and bar graphs. So today's drill is, when should you use a line graph and when should you use a bar graph? Now the answer is, if you guys remember, we use a line graph to show how something changes over time. Remember, we talked about how businesses often use line graphs to show how much money they may have lost or gained over the course of a year. Remember, they often look zigzaggy. Okay, and a bar graph we use to help compare and contrast two data points. We're comparing two different things. So today, what we're going to be learning about is a different type of graph, and it's called the line plot. Now let me tell you right now, a line plot is very easy, something you've probably done before, and is very similar to a bar graph. So let me show you. This up here is an example of a line plot. Now all line plots do is show you the frequency of something occurring. So here's what I mean. Over here on the left I have my raw data. Okay, this is the number of projects each student completed in the class for the year. This data is not. There's nothing done to it. It's in no particular order. This is just as the teacher collected it. Each number here represents the number of projects a student did. So this student right here completed 2 projects. This student completed 4. This student completed 3. This student completed 3. This student completed 0, which is horrible, right? And this student completed 5, so go them. Over here on the right I have my line plot. So each X represents the number of students. Each X represents a student. So, like we said over here, if you guys look through here, you'll see there's only one occurrence of a student completing 0 projects. That one student is represented over here in the line plot with this one X. You'll notice there's 3 X's above the 1. That means there are 3 students who completed 1 project, and we can see that over here in our raw data. Okay, there's the third one. So let's go ahead and start making our own. Okay, this right here, this raw data that I've given you, is from actually earlier in the year. It's rounded. This is from our skipping lab. These are from just some random students. I went through and just collected some random students' data. I didn't do anything fancy to it. I just took their speeds and listed them out for you here. They're in no particular order. I'm not doing any calculations with a line plot. I'm simply marking the number of times an occurrence happened. So in this case, I'm going to be marking how many students skipped up the hall and back in 13 seconds. Okay? But let's talk about the steps in making a line plot. The first thing you need to do is make your original scale down here. Okay? And the best way to do this is to go through your data and find your lowest points and your highest points, and then you can fill everything in between. So my first number here is 13. Is there anything lower than 13? Oh, there's a 12. Anything lower than 12? Nope. Alright, so then 12 is my lowest data point. Okay, Now let's go through here is look for our biggest data point. So there's something bigger than 15. Then 13 is 15. Anything bigger than a 15? Yep, there's my 16. Alright, so I'm going to go through and fill in everything in between 12 and 16 because, oh, wait a minute, Miss Hayden. This is what happens, guys, when you work too fast. What did I do wrong here? There is a data point bigger than 16, and that is 17. You guys have to move slow or you'll make silly mistakes like that. It may seem really easy, but that can often lead to very silly mistakes like that. Okay, so there we go. I have my scale down here all set up, so now all I have to do is graph it. So my first data point here is 13, so I'm going to make an X here. And it's always good to go back to your original, excuse me. It's always good to go back to your original raw data and mark out when you've marked something so you don't count something twice. Alright, so I'm going to put another X above this first 13 because there are 2 students so far who have skipped in 13 seconds. 15. And another 15. And obviously your X's need to be a lot cleaner than mine. And I'll just do this one more 30 here. Okay, oops. Alright, so that is how you make a line plot. So I'm going to let you guys go ahead and finish this up. And when you're done, we're going to come back and talk about how to interpret and analyze this data.